Hello everyone. My plane seems to be making a detour over Alaska. Why is my airplane going out of its way to avoid the Pacific Ocean? Is this a mistake? Did I accidentally sign up for the Caribbean route? At first you might think it was a safety issue. The Pacific is the largest and deepest of the world oceans. If a plane encounters a problem over a seemingly endless and bottomless pond of water, the pilots are going to have a rough time finding a safe spot to set her down. Alaska might not be overpopulated with international airports, but it's a lot better than the middle of the ocean. How's that for a tourism slogan? Alaska, at least it's better than sinking. Okay, I apologize, Alaska. Guessing that it was safety precaution wouldn't be entirely wrong. When planning a route, many pilots prefer to maximize the number of airports along their path. Emergencies are incredibly rare relative to how many planes to take the skies every day. But I can't think of many things more stressful than losing an engine 30,000 feet over the middle of the Pacific Ocean. That said, isn't the main reason airplanes tend to avoid making a straight shot east to west. Ultimately, it comes down to saving fuel and time. It's easy to forget that an airline is a business whose Pacific depends on how quickly and cheaply it can move passengers between destinations. People also prefer to get to their next stop as quickly as possible, so it's a win-win for both airline and passengers. Long story short, which is not my fault, speed is usually the primary factor in determining a plane's flight path. Excluding special circumstances such as a passing through the jet streams or other meteorological concerns, the fastest route is almost always the one closest to the straight line. But wait, just look at that flight path. It's anything but a straight line. Well, yeah, when you look at it on a flat map, but our planet isn't flat now. Is it? It can be confusing since we are used to looking at our world on a two-dimensional plane. Unless you bust out a globe each time you need to check where some city or country is located, or you probably look at a world map. So on a 2D map making a giant rainbow, why the Pacific Ocean look like a much longer route? But since Earth is a sphere, or more or less, but more than the latter, and straight line is going to look very different in three-dimensional spaces. Okay, let's do a little experiment. Got a global nearby. Oh yeah, I just said most of us use Google Maps. Alright, here I will show you on mine. I will put one end of string on Los Angeles and the other end on Tokyo. When I pull it taut, you will notice that the string isn't running exactly parallel to the lines of latitude printed on the globe. Instead, I will bend slightly upward and follow the curvature of this mini earth I got at the bookstore down the road. This effect is even more pronounced in practice because my globe isn't a perfect recreation of the real deal. In fact, the problem is that it's too perfect. You see, unlike a globe, the earth isn't a perfect sphere. Our planet is slightly bigger around the middle, kinda like me after the holidays. Wait, who wrote that? When looking at pictures taken from outer space, the difference isn't enough to notice. The planet is so big that it's easy to lose track of a few hundred miles here and there. But check it out, if you could take a giant string and measure the Earth's circumferences through the poles, you would need 24,860 miles of string. But if you do the same thing at the equator, I would jump up to 24,900 miles. Why is that, you ask? It's because our planet rotates on its axis. Even spin yourself really fast on the playground merry-go-round when you were a kid. Remember feeling like the things was going to throw you out to the sides? No, I remember I was thrown up a lot. Not a good ride for me anyway. Something similar happens to the Earth midsection as to spins. The force causes it to bulge out. Yes, it's spinning fast enough to do that. Anybody tuning in from the equator right now, you are currently moving about 1000 miles per hour. That 40 miles difference in the earth width might not seem like very much. But when it comes to the surface area and entire planet, that little bit of added grid can go a long way. The combination of these two factors, the curvature of the Earth and its extra equatorial width or like that, mean that curving towards the poles is a shorter distance than flying what seems like on a map straight across. None of this to say that planes never cross the Pacific Ocean. People have to get to Australia somehow, I guess. I'm not so much into giant insects and spiders, but had to each his own. Just kidding, Australia. Anyway, planes will also venture over open water to avoid storm, while aircraft can outclaim some types of severe weather such as hurricanes and tropical storms. Seemingly mundane thunderstorms are surprisingly challenging. With clouds reaching altitude of over 60,000 feet, airplanes are advised to steer around instead of into over them. It's almost unheard of the modern aircraft to be brought down by severe weather, but bad enough turbulence can cause injuries to passengers and crew as they and all the stuff they are packed with them get tossed around the cabin. The takeaway here is keep your seatbelts fastened at all times. Another reason planes will sometimes brave on oceanic voyages to take advantage of a smoother ride. Even in clear weather, there is a much less turbulence over the water than over land. This is because the primary source of turbulence is not air rising up from the ground. Hey, there is a lot of hot air rising up from this microphone. Water distributes heat a lot better than soil, so flights over the oceans are often much smoother. The other primary consideration for determining flight paths are air currents, namely the jet stream. These high-altitude air currents exist near the top of the troposphere. That's the lowest layer of the Earth's atmosphere and the one where most weather occurs. The border between the troposphere and the next layer of the stratosphere is known as the troposphere. Its altitude fluctuates between 4 and 12 miles above the Earth's surface. This fluctuation results in rapid shifts in air temperature and pressure, which creates a wind tunnel that can reach a speed of over 200 miles per hour. These extreme speeds are most common in winter when the temperature differences cannot test, but regular wind speed of 80 to 140 miles per hour are nothing to scoff at, so keep your scoffing to yourself. There are 4 main jet streams, 2 in each hemisphere, and thanks to the Earth's rotation, they mostly flow west to east. The 2 most important for air travel are the polar jet stream, which forms near the Arctic Circle, and the subtropical jet stream near the equator. Both are thousands of miles long despite being only a few miles wide. Flying with a jet stream can shave several hours off of a trip, but flying into it can slow the plane down considerably. It's also worth noting the risk associated with jet streams. The biggest hazard is a kind of turbulence known as a clear air turbulence, which occurs along the edges of the streams. This kind of turbulence is nearly impossible to predict and far more intense than the usual variety. Turbulence-related accidents are rare, but they are possible. One particularly serious accident happened in 1997 when a plane flying from Tokyo to Honolulu suddenly dropped after hitting a patch of clear air turbulence. The pilots were able to regain control, but many passengers had been thrown from their seats really hard by the sudden descent. With that danger in mind, flight plans need to be carefully calculated to take advantage of the jet streams without putting the plane at risk. Repeat after me, keeping your seatbelt on at all times while flying. Understand why planes take the routes they do often comes down to facts we don't usually think about in everyday life. The jet streams mostly affect things tens of thousands of feet in the air, and the curvature of the Earth doesn't really matter unless you are traveling hundreds of miles per hour over the vast distances. I don't know about you, but my car can't quite manage either of those things, at least not yet. Okay, if you learned something new today, then give the video a like and share it with the friends, and share. Here are some other cool videos I think you will enjoy. Just click to the left or right and stay on the all-in-one Pakistan. Thank you.